Hello, grade ninths. So today I want to talk about the first of the learning goals that's related to linear relations that we've been learning about in class. Here you can see our graphic organizer, which I've been building and sharing as we go. So today we're going to just zone in on this first learning goal, which says I can represent a relation using a table of values. It says right here, a graph or an equation. So we want to be able to freely go between tables of values, graphs, and equations that are related to linear relations. And the other thing is that we want to distinguish between independent and dependent variables. And this is something that takes a little bit of getting used to, the idea of independent and dependent variables, but it's an important part of linear relations. So let's go to this box here. So what do we see? We see a relation. So let's just talk about relations in general here, not linear relations, just relations. They show how one variable influences another variable. So we're looking at two variables only at a time. And the one that we freely choose is called the independent variable. So that's the one, if we're doing an experiment, that's the one that we're going to change as the experimenter. And then the variable that changes because of that change in the independent variable is called the dependent variable. On a graph, the independent variable is always plotted on the horizontal axis, and that's just a convention that we use in mathematics and science, that the independent variable is on the horizontal axis. And in a table, our convention is that the independent variable is listed in the first column, and then the dependent variable in the second column. In an equation, if we're writing an equation, the dependent variable is always on the left of the equal sign. So let's take a look at an example. So here from the graphic organizer, I'm using this example, and the example itself is listed in the center here. It's highlighted. We've got Chris. Chris runs a window washing service. She charges a flat fee of $5 plus $3 per window. So the first step is to identify the two variables, the two things that change in this example. And the two things that change are the amount of money she charges in total and the number of windows that she charges. And if we look at this sentence here and we sort of read it aloud, we can see that it makes sense if we say it this way, that the fee depends on the number of windows, or the amount that she charges depends on the number of windows washed. It would not make sense to say that the number of windows in the house depends on how much money is charged. That kind of doesn't really make sense. So since the fee depends on the number of windows, you can see the word depend here. If fee depends on something, then the fee would be the dependent variable. So fee is dependent and windows is independent. We're going to do a little practice of that in just a moment. So that's a statement, just in words, of what the problem is all about. If we were going to create a table of values from this statement, it would look like this. So we've got the number of windows, which is the independent variable, in the first column, and the fee in the second column. Notice I don't have a zero here, because if you didn't have any windows, then you wouldn't use this service, so it doesn't make sense to include a zero amount. So the least number of windows, be very unusual to have a house with one window, but the least possible number of windows you could have would be 1, 2, 3, and so on. So we're choosing these values as the experimenter. That's the independent variable. And then we figure out what the fee would be. And from the words here, we can just sort of figure it out in our head. So if she charges $5 as a flat fee plus $3 per window, then for one window we'd have $8. For two windows, $11, $14, $3. So we can calculate these values here. If we go from there right over here to the graph, so important things about the graph: the number of windows is the independent variable, so it would go on the horizontal axis. The fee is the dependent variable, so it would go on the vertical axis. Notice I put units here next to the fee, dollars, in brackets, and then we plot the data points and we connect them with a line. In this case, we're connecting them with a dotted line, as you can see here, a broken line. and that tells us that the data is discrete. And what that means is you can't have any number of windows, in this case, in between these values. You can't have like 1.2 windows, for example. In some problems, we'll see that you can have in between values. That's called continuous data, and then we would use a solid line. In this case, we've got discrete data, so we use a broken or dotted line. Also, we've got an arrow at this end showing that the data would continue beyond there. Notice that I didn't connect the line. I didn't even include a data point at 0 windows, since again we wouldn't really have any data here. If there were no windows, there would be no point in hiring someone to clean them. Down here we've got the equation, and this is sometimes the most difficult part for students to write, is the equation. But if we look at it, once we've defined our variables, let W be the number of windows and F be the fee in dollars, then this equation does describe how the relation. So F, the fee, is equal to 3 multiplied by the W, $3 per window multiplied by the windows, plus $5 as the base fee. So this equation here represents the same relation. It is normal if you have a variable part, especially if the initial value, or the flat fee in this case, is a positive number. It is normal to write the variable part first and then the number part at the end. That's a normal convention that we choose, but we'll look at that some more in a future video. So now I'm here in IXL, and I just want to do a little bit of practice with this dependent and independent variables idea. So I'm in the grade 9 section, as you can see here, and if I scroll down to actually you don't have to scroll down. It's right here in section P2, identify independent and dependent variables. So if I click on that, we can practice that a little bit and see how it works. So here's one example coming up. Okay, this is an American example, not a particularly good one, but let's try it anyway. In the United States House of Representatives, the population of a state is used to calculate how many representatives are from that state. So these are our two variables. P is the population of the state, and R is the number of representatives. So the question is, which is independent and which is dependent? So a good way of thinking about it is to say out loud the two options. So we could say that the population of a state depends on how many representatives are in that state, or we could say the number of representatives depends on the population. And that second statement is the one that makes the most sense. The number of representatives, R, depends on the population, so R would be the dependent variable and P would be the independent variable. So that's our choice. We hit submit, and we got that one right. Let's try this next one, and maybe you can think about this for a moment before we click on the answer and see what you would get. Dakota, a florist, is assembling bouquets of roses to sell at her flower shop. The number of bouquets depends on, now you've got the word depends on here, so that kind of gives you a good clue as to which is the dependent variable. The number of bouquets depends on how many roses are in her shop. So again, we can ask the question, does the number of roses in the shop depend on how many bouquets she can make, or does the number of bouquets she can make depend on how many roses are in the shop? And again, that second statement is the one that makes the most sense. Number of bouquets is the dependent variable, and the number of roses is the independent variable. So we choose that option, and we can keep going like that. So I urge you to, particularly if you're having trouble with this idea of dependent and independent variables, is to practice that using IXL section P2 in the grade 9 area, identify independent and dependent variables. And the questions do progress and get to be more challenging ones as you go along, so you can really master that skill.